Hey there, welcome to another episode of the Dune Analytics tutorial series. And today we are in episode 3.1, and today we're going to focus on creating simple queries and a dashboard. So what we're going to talk about today is we're going to, like I just said, we're going to create some simple queries, we're going to make them into some nice visualizations, we're going to assemble them on a dashboard, and then we're actually going to take a look at the parameter function, which I will explain when we have arrived there. So what will we actually build this dashboard on? That's it's like quite a hard topic for me to figure out, but I figured what is pretty simple and what everyone probably understands is working with gas fees. So there's this nice website which is called fees.wtf. I've already opened it here, and we can just take a look at this, and we can see like it automatically recognizes my address from my MetaMask, and it will just calculate basically how much Ether I've spent, how much that's worth right now, how much gas I've spent in total, how much transactions I've committed, and what the average gas price of those transactions was, and how many transactions failed. So I actually have a 0 here, which is pretty nice. Yeah, but anyways, we are going to recreate this inside of Dune, and we're going to take a look at so total gas spent, we're going to do a transaction counter, we're going to do an average gas price, we're going to do failed transactions, and then we're going to ask ourselves like how could we improve upon this. And I think we'll do this like during the whole process, because this is quite limited since it's only like a snapshot in time. So I'm not okay with this, and I think we can do better on Dune. So we'll like not to shit on whoever created this site. It's pretty funny and pretty hilarious to look at. So yeah, so we're just gonna start, and at the beginning, like we're gonna recreate this for DJ Spartan, for one of his public addresses, because I don't want to dox my address, and yeah, we'll just go ahead with that. And so yeah, we'll just start by creating a new query. And what we have to do first is we have to find the table that we want to work with. So if you've watched my table on the database, you will probably be familiar with this. So we're gonna work with Ethereum.transactions, because Ethereum.transactions has the gas price and the gas used, which is what we're mainly gonna be looking at. And so if we want to verify that we can actually work with this table, we are just going to say I want to select everything from Ethereum.transactions, and I'm just going to limit the table very heavily, because otherwise the query will run forever. Yeah, limiting this query to 1000. Like now you can see like the runtime is 1 second. If I up this to 10,000, then the query will already run longer. Oh, actually it took 0 seconds as well. That's quite, it's a bad example right here. But yeah, now that I've upped it to 100,000 rows, like you can see that the query immediately takes longer. So the more data you're querying for, the longer the query will run. Like that, just like like very basic rule of thumb. Obviously that could like that depends on what kind of query you're actually giving the system, but like the relation between like you query for more rows and the query will take longer to run is quite obvious. So so now that we have this table, we want only the transactions that have been committed by this address. So what we're gonna do here is we can see like the from column that contains the information who started that transaction. So we're just gonna say where, and then we have to put from in quotation marks, because it's also a native SQL operator basically. Like SQL recognizes this as one of its keywords, so we have to put this in quotation marks, so that's why I'm doing that here. And then we will just copy this address and we will paste this address in here. But there's a specialty on Dune in that we have to put addresses in single quotation marks, and we exchange the 0 with a forward slash. that's the way all queries are constructed in Dune. So I'm just gonna run this, and you can press Control and Enter, and then the query will run. So you don't always have to click on this run button right here. So yeah, so now this query run, and we can see like all of these transactions have been committed by this account or by this wallet. So that's what we want. So now we see here like there's 1,059 rows, and if we look on Etherscan, there's actually 1,080 rows. So what's happening here? But that's quite simple to figure out. Etherscan just shows you like inbound transactions as well. So how can I find an inbound transaction? There's an inbound transaction, and it counts these as well. So that's why we see 1,080 here. So just to verify this real quick, we could also do like or 2 is equal to, and then we are just gonna copy this address, paste it in here, and then we get to 1,080 as well. But for our case here, we don't actually want that, so we're just gonna delete this again. It was just to confirm that like we actually have like all the transactions that got committed here. So so now we need to find the columns that are actually relevant for us. So obviously, like I know which columns are relevant. That's why I chose this table in the first place. But usually you can just like watch through here, and then you can find like, okay, I don't need this data column. Like this is useless information for me. I don't need the transaction hash, nor do I need the, I don't know, the nonce or the index. So going back to our first, to our game plan, we need the total gas. So we need the gas costs. We need the transactions, which will basically just be our columns. So that's not really relevant for us as well, or at least no column will be relevant for this. We need the gas price. Obviously, that's that's like kind of the same information. We're just gonna work with that in different aspects. We need the failed transactions, which would actually be the success here. So we can see that he had quite a lot of false transactions, so we need that. And yeah, that's pretty much it. So we're just gonna select what we need. Oh, and the block time would also be helpful, although for a very simple implementation we wouldn't need this, but we're just gonna say, okay, I want the block time, I want the success of the transaction. I can leave out from, because I filtered this here, so there's no other chance that anything else would be in here. The value would be the ether transacted, but that's not relevant in our case as well. I don't need the block hash. The gas limit is not relevant as well, also, although the name sounds like it, but we only need the gas price and the gas used, because the gas limit is just how much would the transaction be able to spend like at maximum, but we actually want the gas that has been used. So we're just gonna select the gas price and the gas used, and I think that is it. So we are just gonna run this again, and now we have a much more manageable table like immediately. So now we can like drill down into these columns, and we can see like the block time. This is fine, although we are probably gonna work with this a bit more. The success column is fine as well. The gas price, that looks quite weird, huh? Like usually, like you can see up here in my add-on, like the gas price at the moment is 37, but this, like the gas price has never been like 1,010,000 or whatever this number would be. So that's because the gas price is in Wei, and to get to giga Wei, so that's the unit we all denominate gas in, we'd have to divide this by 10 to the power of 9, and then we will actually get to gas prices which are reasonable. Is it not 10 to the power of 9? Is it 10 to the power of 8? Wait a second. So I just looked this up, and it is actually Gwei. So 10 to the power of 9, that was actually correct. That's just the unit conversion inside of the Ethereum system, or the convention around naming these different denominations. So so this column is actually correct, and now we can see like it has renamed itself into column because it no longer knows what it is, because we have divided this. So we are just gonna give this a new name. And then we have the gas price. So now, because I'm actually doubting, we can just check the, I think it was transaction hash, but I'm not sure anymore. So we're just gonna check in here again, because then I'm just gonna cross-reference with Etherscan, so that we can actually like see if the gas price is correct, what we're calculating here. So it's just hash, not transaction hash. So we'll just take one of these hashes. I guess we'll take a recent one, because then the gas prices might make more sense. So this here says he has used 23.01 as a gas price, and we are just gonna go into Etherscan, and we're gonna plug in our thing here, and he has indeed used 23.01 Gwei, which is quite peculiar. Like usually people use round numbers, but I guess you could like front run some transactions with that. Not front run, but you get into the queue first, so it kind of makes sense. If everybody else chooses like 23.0 and you choose 23.01, you get taken first, although you virtually pay nothing more. You pay a bit more, but whatever. So that seems to be quite a common topic in this address, actually. Quite interesting to see that strategy. So yeah, so now we're at the point where we can see like how much gas has he used and what was the gas price for that. So now we can let go of our transaction hash again, and maybe I can actually make this query more readable for you guys. That would be nice of me, I suppose. We'll just list these under each other. Everybody has to find their own style, like doing this query formatting, but that's usually like I land somewhere here. So now we have the gas price and the gas used. So to actually see how much the transaction cost in terms of ether, we can now do gas price times gas used, and then we will divide this whole thing by 10 to the power of 18 to get the ether amount used per transaction. So we will just do this, and then we need to rename this as well. So ETH paid for transaction, and then we can actually include our hash again. So you can see we'll just search for the most expensive one. Here he has paid 0.2 ETH for one transaction, which is really expensive. And we'll just take a look at this transaction hash to see if that actually matches up. And we can see here that the transaction fee has been what we have calculated as well. So that's pretty nice. So what we can do now is we can sum this amount. So we can just do an aggregate statement, or we can use an aggregate operator instead of SQL. And if I were to run this query now again, like every time you use an aggregate function, you need to group by these group the query by these other things, because the database basically wants to know like, hey, what do you want to sum this over? And if we just select basically everything in here, so instead of writing like block time, we can just do 1, 2, 3, 4, and 6. And that actually didn't make sense. Because now we have just summed the transaction cost over like each transaction, which is the same. Like that was not the smartest move by me, but I think what we'll do instead, so you can like stay in the logic of this. So I'm just gonna reverse all of this. I wanted my transaction hash, okay. So what we're gonna do here is we're gonna open up a with statement, and we're just gonna call these all transactions, and then we can basically construct a table with this with statement, and then we can just select from this table. So if I just do like select all from all transactions, that was not what I wanted to do. That didn't work. Oh. With all transactions as, of course. And now we get the same table as before. But what we can now do is like we can conveniently work with the data here without having to change this whole query. So because we want some other information from here and we just want to sum the transactions now, we can just do a sum, and then we can just take this name that we've given this new column, and we can say I want to sum this over, and I want to sum this over the block time. Or rather, I could just do, if I don't specify anything else here, it will just sum all the ETH paid for transactions. So he has spent 15 Ether in total. So that's pretty expensive. Yeah, that's really expensive. That's a nice car right there. So now we basically have arrived at, well, we have the total gas spent, or rather we have this number right here. So I've spent 0.61 Ether, and Degen Spartan has actually spent 15 Ether, or a bit more than 15 Ether. So what we could do now, like what would be interesting to see, is how does that like distribute over time. So we could just say I want the block time, and I could sum whatever I'm choosing here over, and then I could say I want to order this by the block time, and I want this to be ascending. So that's basically this like function sum over and then order by something. That's basically a cumulative. I don't know how to like just so that we have the same in mind. Cumulative. what a shitty word. So yeah, that's a cumulative function, and if we just run this now, we can see that we can already build a nice visualization. So sorry if that was too fast. Like I'm just gonna delete this again and show you properly. So we can just click on new visualization here, then we can choose between like what kind of chart do I actually want. So I could make a bar chart, or an area chart, or a scatter chart, a line chart, a pie chart. I could also make a counter, which we can do in a second. It doesn't make sense here, but I'll show that in a second. And then we can just click on add visualization, and then if there was more arguments here, like you can choose the X column. So obviously I want the block time as my X column, and I want the sum. So that's called sum because we haven't given this a name here. So we could just name this as accumulated gas fees. and then it actually says I'm missing my y-axis, so we're just gonna put in cumulated gas fees in here, and then we can see that it arrives at the same value that we had calculated before. So that's pretty cool. So now we are already like this is already cooler than what we can see here, because it's not like a snapshot in time, but rather it's it's over time, so you can see what this address has been doing over time. So that's pretty cool to see. So the next step would be joining US dollar prices, but I think we'll put that away for a bit, because then I can show you some other things. So now I actually want to keep this, so I'm just gonna name my query, like we're gonna call this like cumulated gas fees, so I can just pull it up in a second again. So now we're just gonna select new query, which was actually not smart. I want to fork this query. So if you click fork, you can just get the same query, and because we have we have basically created a table here, like we can also just run this partially. Like basically all the information that I want, like right now, is in this table already. So I can just like work with this like all transactions table that I'm creating in this with statement, and just change whatever I'm trying to achieve down here. So next up was transaction counter. So we can do just like we did cumulative gas paid over time, we can also just count the transactions over time. So we're just gonna say, I think we can just count everything, because one column is equal to one transaction. So we're just gonna say order this by block time, and then we're gonna name this cumulated transactions, and then we just do this. We just run the query, and then we arrive at cumulated transactions. So this is 1056, and if you remember earlier, I think there was 1056 in this. Wait, what's the last value actually? 1059. I guess that's right. There was that many rows in this table that we constructed here. I hope, at least. Otherwise, there's a mistake in this query that we've constructed down here. So we're just gonna. I've just ran this part again. We'll just wait for a second. Sometimes our database is busy and it might take a little while longer. Like you can see, I didn't do anything special. There's just a lot of other people probably working on Dune right now, or somebody else is querying the Ethereum.transactions table. So sometimes we get a bit of conflicts in our database structure, but usually this should resolve pretty fast. That's where I went wrong. I didn't select my this statement down here, so it was trying to query everything. So that's not what we wanted to do. Always be mindful of what you try to query, otherwise you'll sit here for hours. Actually, queries time out after 45 minutes, so yeah, but that's also not what you want. So you can see 1059 rows, so my query down here was actually correct, and that's like first note, like always like check your raw data. Like that's my thought process. Like always, I always like double and triple check everything, because that's quite important. So now we have the cumulated transactions over time. That's also like pretty interesting to see, and yeah, that's pretty cool. So what we could do now as well is we could see like how many transactions has he done in any given week. So for that, we could just do a date trunc. So with the date trunc, that's another SQL operator. We basically cut out single parts of this timestamp, which is block time, and it works like you can give it like a statement here. So week, hour, month. I think minute works as well, but yeah. So basically that, and then I want to count everything, and I don't want to do this cumulative anymore, but rather I want the transactions per week. So we're just gonna do per week, and then we just group this by the week. So by this first statement, we can just call this week as well as week, and if we just run this, and then we arrive at, okay, nice, thank you. I have failed to write week correctly. That is horrific. So yeah, now it doesn't recognize this anymore, and now we can see that a line chart is actually not the best way to display this. So we're just gonna switch to a bar chart, and then we can see like in which week has he committed like how many transactions, and then we can see like the peak has been here, like 65 transactions in a week. That's pretty interesting to know. So yeah, so that's also an interesting query. So I actually don't know if I saved my previous query. That kind of sucks. But we're just gonna say weekly transactions, and we're just gonna save this. And then I am actually gonna roll this query back. So you can just use like in every like text editor, basically you can use like Control and Y and Control Z to go forward or backward with your edits. So nope, that's still not far enough. That's too far. Yep, that's where I want to be. So now we're at cumulated transactions again, and I just wanted to save that query. So this looks, yeah, the bar chart seems to have some problems here. That's weird. So yeah, anyways, now we are at our line chart, and I just wanted to save this. So, oh, this is already saved. Oh yeah, so what I can do now. Oh man, I actually screwed up. Yeah, what we are gonna do is we're gonna just select a new query, paste this in here, and then we're actually just gonna yeah, sorry about that. I just paused the video and fixed that. I was just I overwrote my query, so you might face the same issues at some point. So always be mindful that as soon as you run a query, the query will actually save. So yeah, that sometimes happens. So that's quite unfortunate, but it happens. So I've just recreated this cumulative transaction thing, and we're just gonna leave it at that. We're gonna save this as cumulated transactions. Cumulated. Weird. And yeah, we're just gonna leave it at that. So this time I'm actually gonna fork this, so you can see here like it's a fork of cumulative transactions, but it's unsaved. So now I'm on the safe side. So the average gas price, that's also quite interesting. So for that purpose, we are just gonna say I want the gas price, and I don't need anything else basically, and I'm just gonna say we need the average. And since I don't want the average gas price of a week or something, we can just select it like this, and then we have our average gas price. And now I can actually show you the counter function. So we can just select the counter, and now the counter is like this, and we actually want decimals, so we'll just can I only put in 3 decimals in here? That's interesting. Yeah. So now we have the we have a counter which shows us the average gas price. So we're just gonna call this average gas price of transactions. So yeah, cool. So we're gonna save this as well. Average gas price per of transactions. So what else can we do? Failed transactions. Okay, so we can just we'll just work with the same data set again, and this time we will have to select success from this table, and in this case we will say where success is false. So I hope this works. Yeah, and then we have 43 rows which are failed. So now we can just say I want to count the success, and we actually don't do the selecting up here, but rather we do it down here by basically giving the database a clause, only select the data where the success is false. So you could do this, and then we get 43. What we could also do here is we could open up a case statement. So I could say case when, and then I think it goes like this: when success is false, then count success, and then I could also say, oh, I should call this as false, and then I can say else. We're just gonna indent this. So we're just gonna say case when, and we can just copy this, and we can say true, and we can say true from all transactions, and this is irrelevant then. That is very nice, and I have to end this, and then we can just call this success at or near s case when. Do I have to put this in? I think. Yeah. Something here is wrong. Yeah, I had to figure that out for a second myself, but I think I found the mistake. We basically needed two distinct case statements. So what we're gonna do is we have our one case statement, which is when success is false, then I want to count the success, and then we can actually end the case statement. So I'm just gonna end this as, and we're gonna call this false, and then we're just gonna open up a new case statement, which is case when success is true, then count the success, and then we're gonna call this as true, and this statement is wrong then. And because we're counting up here, we actually need to group this by success. So if I just would delete this for a second, there's a comma missing as well. Yeah, but it basically tells me, hey, you are aggregating something, you need to group this by something. So we're just gonna group this by success, and then we arrive at something that is this. So now we have a counter for false and a counter for true, but you can see that this was way more complicated than what we had done before. So yeah, choose your methods, and of course this is applicable in some cases, and I don't think this is the perfect implementation of this actually. Like, I've not worked with case statement in quite a while, so I'm not too familiar at the moment. But yeah, you can see that it was easier if we just do count success, and we can just say like, hey, where this is false from all transactions, group by success. I don't want to group this by success. I want to where success is false. Yeah, so that is way easier this way. So then we have our failed transaction counter as well. So I thought I'd overwritten a query again for a second. Thankfully I didn't. So we're just gonna create a new counter. We're gonna name this counter failed transactions, and I think fees.wtf gives us so fees.wtf also gives us how much did these transactions cost us, but I think we can leave this out for now. It's not something I'm interested in currently. So now that we've done all the work with like just I've shown you how to do average and sums and counts and stuff like that, we will actually tackle this problem of joining on US dollar prices. So for that we will go back to our query and actually need to save this though. So we'll call this failed transactions. And then we're just gonna fork our query again. And now what we are gonna do is we basically need the price of US dollar for every for each of these. So what we are gonna do for that is we are gonna join the prices US dollar table on this on the table that we have created up here. So what we're gonna do for this, because prices.us dollar only has I can actually show you this table for a second. Prices.us dollar only has prices for each minute, I think. So if we were to join the table on our table now, it wouldn't work because the Ethereum.transactions table also has seconds, and then the join doesn't work. So we're just gonna select something from the prices.us dollar table again, just to see what's going on here, and we can see that it only has the minute. And so what we're gonna do here is we're just gonna select a statement which is date trunc minute. The date trunc thing I showed you earlier, and then we have the minute. I want the minute from the block time, and I want the ETH paid for transactions, and I want this from my all transactions table. So now we have the minute and we have the ETH paid for the transaction in that minute. And what we do now is we start joining another table on this. So this basically works in a way that we find a common denominator. So in this case, we have our prices table, which has minutes, and we have our transactions table, which has minute, and so that the database knows which columns to match. Otherwise, it would just like match everything, and then we would have like the price of yesterday on today, or the price from 5 years ago on today. So we need to tell the database like where can you join these columns on each other, and that's basically what we're doing by saying that it's a left join. You can also like we could also just do this, like we could just put a comma and then write prices.US dollar, but this would just cause puke errors. So we're not gonna do that, but instead we're gonna like do the right thing and join on prices.US dollar. And because prices.US dollar actually has all different kinds of assets, we are gonna we're gonna construct a subquery basically. So what we're gonna do is we're just gonna construct this in here real quick, and we can see that this has a symbol column. So I'm just gonna say where the symbol is equal to, I think it is wrapped ether in here actually, because that makes it easier to work with in most cases. So where symbols wrapped ETH, and then we're just gonna say where the minute is, I think over 21 minus 01 minus 01. This query could run in a reasonable amount of time, but just to be sure, I'm actually gonna just say from the 1st of May, like give me all the prices. Yeah, fucked up here. I wanted to say end. So now we have the price of ETH over the last month, basically. I'm just constructing this query to show you how the price table works, basically. So now we have the table over the last month. This seems pretty accurate, and now we can go back to our failed transaction, not failed transactions actually, to our matching of transactions and gas price in US dollar, and we can just say I want to left join, and then I can just construct a new query in here, and so now I can just delete this, because in this left join statement I basically say like only join the minutes where there has been a transaction actually. So it's not gonna just select everything from this and like create a bunch of empty rows, but rather we say like dedicatedly like only join this where this is actually true. So in order to like say to tell the database where I join this, we have to do this. So I wanna left join this statement on the following parameters, and I think I need to give this a name, so we're just gonna call this prices, and I want to join this on this statement, so on the minute. So we could just do, I'm just gonna call this table A. So man, this is escalating rather quickly. I hope some of you can at least follow me. So what? Let's organize this. I think it could become more clear if I do it like this. So what we're doing here is we're selecting the block time from up here, but instead of getting the seconds, we only want the minutes. So that's why we're constructing a date trunk here. Then we are fetching the ETH paid for the transactions, which we calculate up here. We do nothing with that because it's already in the correct format. It's already like in the like human readable Ether form that we're all familiar with. And then I'm saying, okay, I want these from this table up here. And then what I'm also doing is now I realize like, oh, I need US dollar prices. So I'm constructing a left join, and this left join basically says select, or rather like, here's this query. Please take the values from this query where the symbol is equal to ETH. And now we need to join this table that gets constructed from this query on something. And what we're doing here is basically we're telling the database join this where the minute from up here is equal to the minute in our prices.us dollar table. So we can just say maybe that makes it even more clear. I want the minute and the price from this. Is it actually called price? I think it is called price. Yes, it's called price. Yeah, and then if we just, and now we also we can select from both this table and from the prices.us dollar table, but I only need the price here. So we are just gonna run this query and hope it actually works. So this is now running. And then we can see we have been successful. We still have 1059 rows, so nothing, there's no duplicates that got produced, and the join is actually working. So that's pretty good to know. And yeah, what we need to do now is we just need to multiplicate the ETH paid for the transaction times the price. So ETH, why am I writing this? So ETH paid for transaction times the price, and I think then we are good to go. Yeah, so now we get to the gas paid, the price paid for each transaction. And now what we could do, we have the hash up here, so I'm just gonna include the hash again, so we can double check this with Etherscan, just to make sure that we have actually been correct in our assumptions. It's always good to just take single transactions and actually check if what you have produced in your query is actually correct, because there's lots of ways to screw SQL code up basically. I should probably rename this column as gas, or yeah, we can call this US dollar paid for transaction. And then that's some cheap ass transactions. Crazy. Yeah, but anyways, we want to check if what we have done is correct, and to check that we can just go into the transaction hash, and we can see that he paid estimated transaction fee of the day on the day of the transaction 244, and we are arriving at 263. I can't quite explain that deviation yet, but maybe if we check a few more transactions, we'll notice a trend. So this says he has paid $194 and we are at $189. So I think it's just the price deviation between whatever Etherscan is using and what we are using. Yeah, things like that happen. Like there's different data sources. That's totally fine. Like as long as the ETH paid for the transaction is correct. Like which transaction did I actually open? 0.104. Like we could also just do this, and so I don't have to search for the transaction. Yeah, there it is. And yeah, if there's a small deviation, that's probably due to the price feed that Etherscan is using and we are using in this case. I'm totally fine with that. That's just the nature of data. Like maybe our data is more correct, or maybe their data is more correct. I would think that like we got close enough that that this is all right. So yeah, so now that we've constructed this, at the beginning I was saying like I think this is like kind of unfair reporting, because it's like you really haven't spent that much money on your transactions, but rather that's how much your transactions are worth at the, I mean, it says right here, right? Like right now that's $1,700, but I think more accurate would be to just take the transaction price at the time. So what we are gonna do here is we're just gonna say, so now that we know that this query works, we're just gonna say I only want these two statements, and I want the ETH paid for transaction times the price, and I want to sum this. So what we did earlier as well, like we can also include stuff like that, like calculations in here. So, and I want to sum this by, and then I'm gonna sum this over I think we need to take this whole statement again. Over order by the minute. And in that way, US dollar paid for the transaction. And this is actually the accumulated amount. And then if we just run this, it will hopefully give us the accumulated amount of US dollars Dune Spartan has paid for all of his transactions. So let's take a look at this. It's $13,000. I think at the beginning we calculated that he spent 15 Ether. So in today's US dollar terms, I think Ether is at like 2.7k right now, so that would be more than what it is here. But this would be the more accurate reporting in my mind, but whatever. So if you need to talk to your like CPA, your tax advisor or something, you can just show them this query and show them how much transaction costs you had, and maybe you can set them off from your taxes. Because this is pretty accurate. So yeah, cool. So now we have done that as well. We could also like do the other thing where we just calculate the current US dollar value of that of all transactions, but I don't think that's it basically aids nothing right now. So we're just gonna stick with this, and we are gonna save this query as well, and we're gonna say this is the US dollar amount for all transactions. So now the query is rerunning. So there we go. And now we basically, I think we have like almost everything that I wanted to cover. Total gas spent, transaction counter, average gas price, failed transactions. Yep. We have all of that. So what I can do now is I can just go to create a new dashboard and assemble all of those, which is really fun. So we're just gonna call this gas tracker dashboard, and then I'm just gonna say save and open, and then I'm just gonna click on edit. I'm not in the way. Then I'm gonna add a few visualizations, and now it's like I want my line chart. So now, like, it lists the last queries that you ran, or that you created, I think. And now we can just add the individual visualizations here, and that way we can assemble our dashboards. So I think that was it. If I didn't, average gas price. Yeah, I think that's one more. Then we're gonna say done, and then we can assemble these. So the US dollar amount for all transactions, we could also, I think what would be interesting here is like if we just do a counter, which is all transactions, and for that reason we're gonna say US dollar spent on transactions. It doesn't seem right. Oh, I can use spaces in here. No machine needs to read this. And we're just gonna give this the dollar prefix, and I'm gonna say this is what I want. And now we face the issue that like our row number, like it's not row number 1, but rather it's row number 1059. And because this could change, like it would be pretty dumb to just say like, hey, this is row number 1059, because then if a new transaction gets committed, then it's no longer relevant. So what we will do here is we can order our query by something. So we're just gonna say like order by, I think, how do we do this? We're just gonna call this, no, actually we don't need to call this. Just gonna say this, order by the date trunk, and then we are just gonna say descending or ascending. I think descending. Yeah, descending. And then we always have the last value on the very top of our table. So there we go already. So we have spent this amount, and now I have this counter. Now I can just go back to my my dashboard thing. I can just add this counter, and here we are. US dollar spent on transactions. So that's very nice. So failed transactions, rather uninteresting stat in my mind. Yeah, we can see the accumulated transactions over time. The weekly transactions, actually we chose the wrong chart here. I wanted my bar chart. Weekly transactions, there's my bar chart. So we're just gonna delete this, and accumulated gas fees. I guess we could put this under this. Yeah, I guess that's fine. Accumulated transactions. Yeah, I haven't thought about how to assemble these on a dashboard before, so that's why it looks like a bit of chaos right now. Yeah, I think something like this. It's not really relevant for showing you right now. Just you could see how I can edit stuff on here. It's pretty easy. I could add text boxes, so I could just kind of write a test in here. These text boxes support simple markdown, so you could do like I think one hashtag is title. Yeah, then the font gets bigger. You can even upload pictures in here and stuff. Yeah, all kinds of good stuff. So the last thing I want to show you is the parameter feature. So if we just remember this. So we have created simple queries, we have created visualizations. Now we have assembled them on the dashboard, and now I want to show you the parameter feature. So what we are gonna do here is we are gonna clean up for a second. I don't need this query anymore. I don't need this. I don't need any of this. So yeah, parameters. So we're just gonna click done, so we can actually open our queries again. And what I want to show you here is that instead of just having this for Dune Spartan or just for my address or any address, we can now, like, we filtered here for an address, and we can just make this dynamic. So we could just say I want to add in parameter, and then this is the parameter name, and it will be a text, and the default is, yeah, now I actually need the, no, I actually do need the address again. I already deleted it, so that's it's pretty bad, but we're just gonna take it again. I think that's correct. So yeah, because Dune doesn't like usual addresses, we're just gonna say yep, that didn't work. Nice. Think like this. We're just gonna paste this in here. Then the query runs, and then we basically get the same, like, we run the same query, but now we can, like, exchange the address with this parameter feature. So what we could do now is we could just go to etherscan.com, and I'm just gonna, like, randomly select a lucky winner to be our test, and then we can just run the same stuff. Run the same query and get the results for different addresses. And yeah, so here we can see this address is actually it's an address all the way back from 2018, but he only reactivated this address like in the last couple of months. And since he has spent almost 50k in gas fees, which is pretty intense. Maybe this is a contract as well, but rather unlikely if it comes from 2018. Yeah, but anyways, so that's how you would work with parameters. And what we see now, if we go back to our dashboard, I'm just gonna go to, actually need to go to my creations, gas tracker dashboard, and then you see a parameter up here. And what we could now do is we could include this parameter with exactly the same name in all of the different queries that we wrote, and that way we would get we can basically make this whole dashboard dynamic. So, oh yeah, of course I didn't put anything in here now, so now I need to find an address again, our lucky winner. So we're just gonna do that again, delete this, just gonna run this, so it actually saves. I think if the query fails to run, unterminated string. That is not very nice. I think we need 2 of these. Nope, only 2. What's cracking? Nope. Like this, yeah. So now we have 2 already that are dynamic. So if we go back to our dashboard, I think we changed this and we changed that. So now if we just choose a new lucky winner, we can just plug this address up in here, and we can click on apply, and then you can see that like the queries that I have just changed, they are actually running now with this new address that I gave them, and these values will change now. It's quite unfortunate that they're taking so long right now. Just gonna pause the video. Yeah, so the queries ran through, and now we are here. So this is a fairly new address. He has spent an average gas price of 83, and he has only started on May 9th. So yeah, all fairly interesting, but yeah, these didn't change now. I'm gonna do that like off screen and share this dashboard below the video, so you can actually like check it out for yourself. And I hope that this video has been useful. Yet again, it has gotten pretty long, but I just think there's no other way to like properly teach this. Yeah, apologies for my mishaps, but I guess you can also learn from them. And yeah, happy querying, and I see you in the next video. Bye bye.